System 1 loaded.
We are now going to get the custom subnet mask of this network address with the given number of needed subnets and the number of usable hosts. But before that, we are going to get first the address class and the default subnet mask for an easier way. So, since the first octet of our network address is 217, it is in the range of class C, which is 192 to 227. So we are just going to write here class C. So since it is class C, the default subnet mask will be 255.255.255.0. Now, we're going to get the custom subnet mask. In getting the custom subnet mask, we're going first to write down our network address, which is 107.10.10. Then convert the host address into octet. So 0. There we are. Then now, we're going to write down the decimal value from right to left. Next thing we are gonna do is write down the number of subnets from left to right. The next step is write down the number of hosts from right to left. Now we have this table. We are now gonna look for the number of needed subnets, which is 13. So in this line, in the number of subnets, we're gonna find the number 16. But in this case, there is no specifically number 13. So we have to find the nearest number from after the 13, which is 16. So we're just gonna encircle it. Then the next thing is the number of usable hosts, which is 13. So we're just going to do the same as we did in the number of needed subnets. So encircle this, the nearest number after the 13. Now we're gonna draw a straight line in the middle of the two encircled value. Then we have this table. So, in getting the custom subnet mask, we're just gonna look for this value before the straight line. So we have these 128, 64, 32, and 16. We're just gonna add it all. So it is equal to 240. So there you have our custom subnet mask. So we can now fill this blank. So 255.255.240. There you have it, the custom subnet mask of this network address. So now, the next thing we're gonna do is to get the 6th subnet range. Let's just insert it here. So, in getting the subnet range, we're going to apply the pattern in rules of addition of the binary and bits parallel. So we're just gonna simply then follow this rule. 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. We don't have to go a further more, since we are just going to find the 6th subnet range. So we are just simply going to multiply with this number. So here in the first, we are just going to write our IP address with network address header. So since it is 0, 16 times 0 is 0, so we are going to write here is 0. So the next step, just follow it here. 16 times 1 equals to 16. Then the next thing is here, write it again. Then 32 times 1 is equal to 32. Then 16 times 0 it equals to 0. Just add the value. So it is going to be 32. There. Next. Since there are 2 1, we are just gonna simply add these 2. 32 plus 16 is equal to 48. There's only 1 1, and it is in the 64 value. We're just gonna add 64. There is 2. It will be 64 times 64 plus 60 equals 3. Since there is also 2 1, we're just gonna simply add 64 and 32, and it will be 96. So in getting the range, it is simple now, as we look for the value of the host address, which is 16. So we're going to in this line, it is indicated that it is 16, so we are going to 15. Same goes with others. 32, 31 headers inside. since we don't have the next binary, we're just gonna count from here to the 6th, which is 1, 2, 3, 4, 5, 6. So this will be the 6th subnet range. So we're just gonna write it down here. 1, 7, 10, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. So there you have it. We are now able to get the 6th subnet range. In this video, the decimal that we're gonna use is 178. Now that we have a decimal, the question is how to get the binary, octa, and hexa using our given decimal. Let's now go first to binary. In getting the binary, we just have to divide the given decimal, which is 178, into 2 using synthetic division. Just like this, divided by 2, which is equal to 89. Since it has no remainder, we're just going to write 0 here. Then do it again. And it is equal to 44. Since it has a remainder, we're going to write 1 at the next. Then again, it's equal to 22. Has no remainder, 0. Again, 11 has no remainder, 0. Again, 5, it has a remainder, just going to write 1. Then divide again, 2 has a remainder, 1. Divide again by 1. Since it has no remainder, just going to write 0. So the next step is you're just going to list all the remainder from below to upper. From below to the top. Just like this. 1, 0, 1, 1, 0, 0, 1, 0. Now that we have a decimal, we are now going to write our binary here, which is 1, 0, 1, 1, 0, 0, 1, 0. So the next thing I'm gonna teach you is the octa. In getting the octa, you're just going to write your binary here. 1, 0, 1, 1, 0, 0, 1, 0. I'm going to teach you the easiest way possible in getting octa. In the means of that, you're just going to divide this given binary into 3. You're just going to count 1 to 3 from right to left. 1, 2, 3. 1, 2, 3. Just like that. And the next step is just write a number decimal. Just like this. 1, 2, 4. 1, 2, 4. 1, 2. And multiply it. 1 times 0 is equal to 0. 2 times 1 equals 2. 4 times 0 is equal to 0. And so on. As you can see, there are 2 numbers in the given pattern. We're just going to add equals to 6. Right? We're just going to list Now we have a octa. We're just going to write here our octa, which is 262. And the last thing I'm gonna teach you is getting the hexa. In getting the hexa, you're just going to do the same as we did in octa by writing the binary, which is 1 0 1 1 0 0 1 0. The easiest way possible in getting hexa is just by dividing the given binary into 4 from right to left. Count 1 to 4 from right. 1, 2, 3, 4. Then divide 1, 2, 3, 4. The next thing we're gonna do is just write a number above, just like this. 8, 1, 4, 8. And the next thing is multiply it. If the binary is 0, that means it is 0. So you don't have to write it down. Only the in each divisor, in each pattern, you're just going to add the numbers. Just right, bring down here the 2, then add 3 plus 2 plus 1 is equal to 11. As you can see, the number that we got here is 11. This is the thing that you must remember. If the number is from 10, it means that it will be equal to A, 11 equal to B, 12 equal to C, 13 equal to D, 14 E, 15 F, 16 G, 17 H, and so on. So that means that this 11 is equal to B. Just bring down, add these 2. Now we have our hexa. It's going to write hexa here. Now we've got the results from decimal to hexa. First thing I'm gonna teach you here in Cisco is the most basic, which is PC to PC. So for the first step, just go to End Devices, then choose this PC. Place it here, and do it again for another PC. The next step is to click the first PC, go to Desktop, and go to IP configuration to place your IP address. So for this video, I'm gonna use 10.10.10.1. For the next step, this is just an option, but I usually use this to know easily the PC. Just rename the PC with your IP address 10.10.10.1. Click again to the second PC. Click the PC, go to Desktop, go to IP configuration, then IP address. Since we use 10.10.10.1, we are now gonna use here is 1.10.10.2 since it is not valid to use the same IP address. But you can choose naman any other IP address that you want. Then rename it again 10. So we have now two PC with IP addresses. So in connecting the two PC, just go here at connections. Then you can see here so many types of connections. As you can see, there are two connections that is blocked na magkatabi. Remember that using copper straight through, we only use this if the two devices is different. And we use copper crossover if the two devices is the same. So in this case, since this is the same PC, we're gonna use copper crossover. So click it, click the first PC, fast Ethernet, then the second PC. As you can see, there are two circles that is color green. That means that the two PC are now connected. So if we want to know that the two PC are really connected, just go here at the mail ping, click, then click to the first PC, then second PC. After that, just go here. Look at these two different things. This is the real time, then this is the simulation. Just click this auto capture play. And we can see the message is delivering to PC number 2. And then going back to PC number 1. In that case, that means that the two PC are really now connected. So that's all for PC to PC. The second thing I'm gonna teach you is the PCs with one hub. First things first, go to Hubs, then choose the first generic, then place it here. As you can see, there are 6 Ethernet space for cables, so we are able to use 6 PCs. Next thing is go to End Devices and choose PC, then place it here. Do it for 6 times. Place 6 PC. So the next thing is to add an IP address to the PCs. Go Desktop, IP configuration. So for this thing, we are gonna use 192.10.10.1. Then rename the PC. Do it again to another PC. since we are not able to use the same IP address, we're now gonna use 192.1.0.1.0.3. Rename. Then do it again to the rest PCs. Since we have now a PCs that has an IP address, we can now connect it to the hub. I'll just rename the hub. So as I said earlier, that for the two devices that is different, we will use the copper straight through. As Ethernet, as you can see, there are 6 ports. Do it again to the rest PCs. As you can see, there are 12 circles that is colored green. That means that all 6 PCs are now connected to the hub. So for us to be sure, do again the email thing. Click the email. Let's do it right there. Just do it to all. As you can see that the message is delivered to the all PCs, but as you can see that the other PCs is X. So that means that this is the only PC that will be delivered by the message. Do it again. So we are now able to prove that our PCs are connected to each other using the hub. So that's it for PCs with one hub. And I'm gonna teach you is the PCs with one switch. First things first, go to switches, then choose the generic, the first one, then place it here. As you can see, there are only 4 ports in this switch. So that means that we can only use 4 PCs. But first, rename this PC. This switch rather. The next thing is go to End Devices, then choose PC. Do it for 4 times. So the next thing is add an IP address to all PCs. for this thing, I'm gonna use 200.1.1.1. Rename the PC. For the next PC, we're gonna use 200.1.1.2. Rename. Do it again. Since we have now 4 PCs that has an IP address, we can now connect it to the switch. Since PC and switch are different things, we're gonna use copper straight through. Choose this fast Ethernet 0, 1. Then do it again. As you can see, there are only 4 circles that are green, and there are another 4 circles that is color orange. That means that our PC are still connecting to the switches. As you can see, the first PC is now green, also the second, and for the rest PC. And do it again for the rest PC. So now, as you can see, they are all connected. So if you want to know that the PCs are connected to switches, let's do this thing again. But we're gonna use only the 4th PC and the 4th PC. Go to simulation. As you can see, that the message is delivered to the 4th PC and going back to the 4th PC. We are now able to know that the PCs are connected to each other using the switch. That's all for PCs with one switch. The last thing I'm gonna teach you is a little bit hard, so you better watch and listen carefully, because this is PCs with 2 switches. So first thing we're gonna do is go to switches, then choose 2960. Since we need 2 switches, we add another one. Now we have 2 switches. We're just rename it first. This is just an option. So, okay, not good. As you can see, there are so many ports in each switch. 24 ports in total. Since there are so many ports in each switch, we're only gonna use 4 PCs in each switch. So go to End Devices, choose the first generic, which is the PC, then add 4 to the first switch. Then do it again to another switch. So the next thing we're gonna do is to add an IP address to each PCs. We're gonna start first to the switch 1. For this switch and PC, I'm gonna use 10.10.10.1. Rename, then do it again. So we're now going to the second switch with 4 pieces. So for this switch with pieces, we're gonna use an IP address that is 192.10.10.1. Rename, then do it again to another piece. So we have now pieces that has an IP address. So the next thing we're gonna do is to connect the pieces in the switches. Go to connections. Since we have different device, which is the switch and PC, we're gonna use the copper straight through. As you can see, there are a lot of ports available in switch. But we're gonna use the first thing or the first port. Do it again to another pieces. And again. And again. So we have now switches that is connecting to 4 pieces. Now let's go here to switch 2. We'll just do the same that we did in switch 1. Connect the PC1 to the switch, PC2 to the switch, again, and again. As you can see, the pieces are now connecting to the switch. So now, the question here is how we are going to connect the all pieces using the 2 switches. How we're going to connect the switch 1 to switch 2. In that case, we are going to do is go to routers. Then choose the 2911 here. As we connect the PC to switch, we'll do the same in connecting switch to router. We're gonna use the copper straight through. As you can see that there are 2 different ports in the switch 1. That means that it can be used to the router. So we're gonna use the first port. Connect. Then choose this. Then do it again to the switch 2. As you can see, there are 4 circles, 2 in each switch and router that is color red. That means that the switches aren't connected, are still not connected to the router. So in order to connect the switch to router, we're just gonna add an IP address. Since we use Gigabit Ethernet 00, For force switch, it will be gonna use to connect the switch 1. I'm going to use an IP address that is 10.10.10.7. We'll do it again for the switch 2 since we use gigabit Ethernet 0, 1. We're going to use 192.1.0.10.7. As you can see that it's still red. The circles are still red. What we're just going to do is to fast forward time, as you can see here. As you can see, the router and switch aren't still connected to each other because we miss something that is very important. So go to router, then go to the gigabit Ethernet 00 which were connected to the switch 1. Then as you can see here, there is port status that is currently off. We're just going to do is to turn it on by checking it. As you can see now, the router is connecting to the switch 1. We'll do it again for the switch 2. Since we use gigabit Ethernet 01, we're going to open this to connect to the switch 2. As you can see that it is connecting for the things to be forwarded. We're just gonna use this fast forward time. As you can see now, the switch 2 and the switch 1 are now connected to the router. That means that also the PCs in switch 1 and switch 2 and switch 1 are now also connected to each other. The first step is to ready the equipment that you're going to use. So this will be the equipments. First is the UTP cable. Second is the patch panel. Third is the patch tool. And lastly, since we don't have a wire stripper, I'm just going to use this cutter. So second step is to get your UTP cable and strip it using this cutter. Just a 1 inch. So that's it. So let's just hiwa-hiwalayin natin. Just like this. Please don't mind the background sounds, noise, etc. because that is just my neighbors. This is the second step. Third step, I think. And the fourth step is to arrange this color using the patch panel T568B color order. So that will be the order that you'll see in your screen. So the first color is brown. Second is the white brown. Third is green. Fourth is white green. Fifth is orange. white orange, blue, and white blue. So this will be the color arrangement. After this, get your patch panel and insert the color. I insert the wire in this space. So first is brown. Second is white brown, green, white green, orange, white orange, blue, and white blue. So it is better to strip the wire a little bit longer for an easier way to insert the wires. Cable, I mean. So the next step is get the patch tool and just insert it down. Just like this. Just push it down. Just don't pressure it hard. That may cause a pagkasira. So it will just, to cut the excess cable, you just have to insert it and press it just like this. So that's it. That's it for this patch panel.